Welcome back, Geometry Scholars. We're going to be doing Skill 5.2 today, which is coordinate distance and writing coordinate proofs. Now, you actually don't have to look very far to see really good coordinate proofs, because if you look at the critical thinking question on the last test, um, here's some actually really good examples that are top notch, that actually do a really good job of providing evidence, thought process, using definitions. So, one thing that we even kind of see here is in this one student, they cite the Pythagorean theorem. They show how the Pythagorean theorem works. So, for instance, you could actually find like the distance from C to B just by kind of treating it like a squared plus b squared equals c squared problem. And this is, a really nice job. I mean, they use the evidence, they use the definitions, and they are using the computations appropriately. The proof on the right actually uses the distance formula and explains how the distance formula is used and even relates it to the Pythagorean theorem as well. So we're going to talk about how everyone can kind of rise to the challenge and write really good coordinate proofs like these today. Pardon me here, I got my cat, so Tipper might make an appearance in the video. All right, so what we want you to do today, I know you might be tempted to kind of look at the bell work and the key, if you're having the sub, but I like you to actually try out constructing your own congruent segments and congruent angles, explaining the thought process, because that's actually going to help you understand the process of writing the proof better and thinking about the why. You can also use protractors as well to copy congruent angles. So there are multiple correct answers to these. But what we want you to do is just kind of do a little bit of experimentation before you go to the key. And what we want you to kind of be thinking about is how does the justification change when you are actually going to a graph instead of on the paper. All right. So one thing that you do want to kind of take away are your quick notes for today. And we're not going to learn anything like explicitly new other than kind of taking what we learned last unit and learning how to find evidence. There are two ways that you can show sides are congruent. So you can use either the distance formula or you can use the Pythagorean theorem. So kind of connecting the Pythagorean theorem into the distance formula. So let me just kind of remind us here that that's the Pythagorean theorem in disguise. Now, if you're having a question about showing angles congruent, the angles that we can show congruent are only kind of the right angles. But if you have perpendicular lines, you'll actually be able to show. So like, for instance, if I'm going like up 2 over 1 and kind of having a positive slope like that, and then maybe for the other one, instead of going up, I'm going to go like down. I'm just going to use like a different color for that. Yep. So like down 1 over 2. We can kind of see that that red line and blue line make 90-degree angles. So you could use your slopes of perpendicular lines to show that certain angles are right angles or congruent to one another. So let's actually take a look at a specific example. explaining why the triangles are congruent to each other. So here is a triangle congruence proof here. And we want to be able to kind of use distance formulas and pictures. So maybe I'll kind of just color code for each one. So I'll just start with AB. And if we notice here, AB, I'm just going to kind of go in red here. So that's the red triangle. It is a 2 by 2 right triangle. And likewise, it's just 2 by 2 in the other direction as well. So if I'm looking at AB and AB prime, or A prime, B prime, I can say that they are congruent to each other. And I can do that because I can kind of look at a 2 by 2 triangle and see that they are the same. And if they are the same, I'm actually just going to do a calculation for one of the triangle, and that's enough to provide the reasoning for the distance. So this is going to be 4 plus 4 equals to d squared, and it does not say anything about radical form. So you can just keep the answer in kind of that unsimplified radical form just to kind of connect and see where it's going. So that's going to be square root of 8. And then this triangle over here is going to be square root of 8 as well. Then I'm going to go and look at the BC triangles. So I could say that BC is congruent to B prime, C prime. And I'm just going to draw a triangle. So it looks like it's a 3 by 4 triangle. And it's kind of a 3 by 4 kind of turned on its other side, the other way around. And if I kind of just draw that triangle there, like 3 by 4, and find the distance for that, I'm going to do 4, 3, I could say that 3 squared plus 4 squared equals distance squared. That's going to be 9 plus 16. Equals to the distance squared. And just make sure you're square rooting. This one is a nice perfect square. So it's actually just going to be that the distance is equal to 5. All right, and then last but not least, we're going to do the last piece of evidence, and that is the AC is congruent to AC. And maybe I'll do like a lime green for this one. But if I'm going right 2 down 5, I could say that AC and A prime, C prime are congruent to one another. And I could do 2 squared plus 5 squared. Find what that distance is going to be. That's going to be 4 plus 25 equals to d squared. And that's going to get us to square root of 29. Of course, if you wanted to, you could go and find the decimal as well. But we get square root of 29 for the missing side. And then likewise, on this triangle, we get square root of 29 as well. Now, I should say that before you do the proof, and if you're struggling a little bit with the computations, you might just want to make the visual observations. So even just saying that AB is congruent to A prime B prime, and BC is congruent to B prime C prime, kind of shows that you already are kind of getting the structure of the proof. And then we're just using our calculations in the diagram. And at the very worst, it's better to even just say, oh, I used a Pythagorean theorem to show that the sides are congruent to be able to get there. And you can kind of take a look at the solution as well, but I kind of wanted to do it in real time just so you could see the process. Now, one thing that I do want you to do before you go to the IP worksheets tonight is I want you to actually kind of look at kind of a mid-grade sample student work question here. So this is explaining why is the triangle below isosceles right? And I want you to kind of think about what are some things that are strong about this response that are going to, lead to him to get points. And then what are some things that maybe, they need to look at a little bit more to get that full mark or points in there. So just kind of think about that before you actually kind of create your own. So for the IP today, I do want you to remain seated. Actually, forgot to change it to scale 5.2. So let me just correct that there. And it is a worksheet. And it will be important that you are showing your work on there. You'll get a nice review of the distance formula as well. So feel free to use the distance formula or the Pythagorean theorem. And please, as always, reach out to me if you have any questions. You can email me or come to my office hours, and I'll be happy to work with you. So thank you very much, and happy studying.